Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are discussing the definition of parametric function, that when the function is said to be parametric, and later on we will prove an important theorem in which we will see how to find out or a formula to find out derivative of parametric function. So first let us try to understand what is the meaning of parametric function, and later on we will prove the formula to find out its differentiation. So now our original variables are what? X and y are our original variable, where x is called as independent variable and y is called as what? Dependent variable. So if the values of these variables are expressed in terms of another variable, so that first see the definition. If two variables x and y are defined separately as the function of an intermediating variable t, means our original variables are what? X and y, and their values are expressed in terms of another variable t. At that time, this new variable t is called as parameter and the function is called as parametric function. We will try to understand this definition with the help of one simple example. So let us consider a standard circle. Standard circle means its center is at what? Origin. Let us denote the radius of this circle by what? R. Let P is one point on this circle. Let the coordinate of this point are say x and y, and radius of this circle will be equals to what? R. Okay, so now as the position of point changes on this circle, its coordinate will get changed. जैसे जैसे point की position circle पे change होते जाएंगी, if I am shifting this point P on the circle, at that time its coordinate x and y will changes. Changes means what? Varies. Varies means what? Variable. इसका मतलब x और y की वैल्यू वेरी हो रही है, इसका मतलब x और y क्या है? हमारे वेरिएबल है, ओरिजिनल वेरिएबल है. नाउ आई एम सपोजिंग दैट दिस सेगमेंट OP makes an angle theta with the positive direction of x-axis, isn't it? Let OP makes angle theta with the positive direction of x-axis. Draw one perpendicular from point P on the x-axis. Denote the foot of perpendicular by M. Now we are trying to find out sides of this triangle with the help of this coordinate. We know that x coordinate means distance from y-axis. This distance is equal to how much? X. If this distance is x, means we can say that OM is equal to x. Y coordinate is distance of a point from x-axis. So here this length PM will be equals to y. Once all the sides of this triangle are known to us, let us try to find out value of cos theta. Cos theta is defined as what? Adjacent upon hypotenuse, means here we will get x upon r, which implies that x is equal to what? R will get multiplied on this side, r is equal to cos theta. And according to definition of sin theta is defined as what? Sin theta is opposite upon hypotenuse, means here we will get y upon r, which implies that y is equal to r sin theta. Now here observe the value of x and y. Value of x is equal to r cos theta and y is equal to r sin theta, where r is nothing but radius. ये point कहीं पे भी move हो जाए ये circle पे, radius does not changes, means r is what? Constant. R remains constant because it is radius. Wherever the position of point P is there on the circle, r will remain what? Constant. चलो अब थीटा के बारे में सोचते हैं. जैसे जैसे पॉइंट P की पोजीशन चेंज होते जाएंगे, that angle made by OP with positive direction of x-axis also changes. As the position of OP changes means if position of point P changes, at that time this angle also changes. If this angle theta changes, means we can say that theta is the variable. जैसे जैसे पॉइंट P की पोजीशन चेंज होते जाएंगी सर्कल पे, at that time angle made by OP with positive direction of x-axis also changes, and the value changes means value varies means theta varies. That's why we can say that theta is nothing but what? New variable. And here we can observe that value of our original variable x and y is expressed in terms of new variable theta. X is also expressed in terms of theta and y is also expressed in terms of theta. At that time this theta is called as new variable, and this new variable is called as what? It's called as parameter. Here that new variable we have denoted by t. in this example, what new variable we are getting? Theta. So here we can say that theta is the parameter, and these functions are called as parametric function. Means our values of variable x and y is expressed in terms of new variable, then that new variable is called as parameter and the function is called as what? Parametric function. Hope the definition of parametric function is very clear to you with the help of this simple example, isn't it? When we can say that function is parametric, if our original variable x and y is expressed in terms of new variable, that new variable is called as parameter and the function is called as parametric function. Now we are trying to prove an important theorem to find out differentiation of such functions, means parametric function. So let us try to prove this theorem. Now first observe the given condition in this theorem. What is the condition? If x is equal to f of t, means x is the function of which variable? T. So here let us suppose that we are trying to draw the rough sketch. So here easily we can observe that this x is the function of t, and this function is denoted by what? F. Isn't it? Now observe the second condition, and y is equal to g of t, means y is also the function of t. So y is also the function of what? T, and this function is denoted by what? Denoted by g, means x is also the function of t and y is also the function of t. In this case function is denoted by f and this second function is denoted by what? G. Also what is given to us that x and y are a differentiable function of t, means x is differentiable function of t. Symbolically it will be denoted by what? Dx by dt. X is differentiable function of t. And if x is differentiable function of t, means x will get differentiate with respect to t, then according to definition of our derivative, which limit exists? Limit डेल्टा टी टेंस टू, यहाँ पे dt है तो यहाँ पे क्या होगा? डेल्टा टी टेंस टू 0, यहाँ पे dx है तो यहाँ पे डेल्टा x होगा और यहाँ पे dt है तो यहाँ पे डेल्टा t होगा. Means if x is differentiable function of t, then it will be denoted by this notation. If this differentiation exists, means this limit exists, or in other word we can say that if this limit exists, at that time we can say that function is differentiable. And what is the given condition? Function is differentiable. इसका मतलब ये limit already exist हो चुका है. Now y is also the differentiable function of t. Y is differentiable function of t, then it will be denoted by what? Dy by dt. This is given condition. If this differentiation exists, means which limit exists? Limit delta t tends to 0. यहाँ पे dy है, इसका मतलब यहाँ पे delta y, और यहाँ पे dt है, मतलब यहाँ पे delta t. So if this limit exists, at that time you can say that function is differentiable, but it is already given to us that function is differentiable. Its meaning is that limit is already exist. These are the given conditions. Using which we have to prove that y is differentiable function of x. और हमें क्या prove करना है? y is differentiable function of x and its derivative is given by this formula dy upon dt divided by dx upon dt. We have to prove that y is differentiable function of x, and to find out this differentiation we have to apply this formula that dy upon dt divided by what? Dx upon dt. So let us try to prove this theorem using the given conditions. Okay, so here proof. Now already it is given to us that x and y are function of what? T. If the value of t changes, let us denote the increment in the value of t by delta t. If the value of t changes, then correspondingly x also changes and y also changes, because x and y are the function of what? T. So let us denote the change in the value of x by x plus delta x, और y की भी वैल्यू चेंज हो जाएंगी तो चेंज डेल्टा y से डिनोट करते हैं यहाँ पे y plus delta y. Isn't it? So write down all these things. Let t changes to t plus delta t. Correspondingly x changes to x plus delta x and y changes to y plus delta y. Already these things we have shown in the figure. This is nothing but rough work. Just we are observing what are the given conditions here. Now we will require one important step important result which we have to or which is helpful to prove our required result. तो पहले उसे proof करके रखते हैं. So as delta t tends to 0, let us see delta x tends to what? So delta x is equal to, can I write delta x as delta x upon delta t, means simply I am dividing by t, and since I am dividing by t I am multiplying by t. Now we are using here given condition, delta x upon delta t as delta t tends to 0. Delta x upon delta t as delta t tends to 0 will be dx upon dt. This is the given condition, already we have discussed on it. So delta x upon delta t as delta t tends to 0 will be equal to dx upon dt, and this delta t I am replacing by its value 0, and 0 into any number will be equals to 0, means what result we have got here? As delta t tends to 0, delta x also tends to 0, delta x tends to 0. So let us denote this result say by equation number first. We have to make the utilize of this result to prove our important formula. अभी एक randomly हमें step लेनी है observing our required result. What is the left hand side? dy by dx. तो हम इस side में लेंगे delta y upon delta x is equals to, okay, and now on the right hand side, to get our right hand side, I am dividing to numerator by delta t, and since I am dividing to numerator, that's why I am dividing to denominator also by delta t. Now if you will observe our conditions here, limits are there, means to use this result we will require limits also. That's why I am taking limit as delta t tends to 0 on both sides. So taking limit as delta t tends to 0 on both sides. Let us see what we will get if we are taking limit on both sides. On this side we will get limit delta t tends to 0 delta y upon delta x, and on the right hand side limit delta t tends to 0, numerator is what here? Delta y upon delta t, and denominator is delta x upon delta t. Now on the right hand side we are taking separate limit of numerator and denominator. So take separate limit of numerator, limit delta t tends to 0 delta y upon delta t, and in the denominator limit delta t tends to 0 delta x upon delta t. Just simply we have taken separate limit of numerator and denominator. On this side delta y upon delta x, and here limit also keep it as it is. Now just delta t I am replacing by what? Delta x. Delta t I am replacing by delta x from which equation? From equation number first. अब यहाँ पे delta x ही क्यों चाहिए? क्योंकि यहाँ पे delta x है तो यहाँ पे भी लिमिट delta x tends to 0 ही चाहिए, तभी हम जाके ऐसे डेफिनेशन यूज कर सकते हैं. जैसे यहाँ पे delta t है तो यहाँ पे delta t tends to 0, delta t है तो यहाँ पे delta t tends to 0, तो यहाँ पे delta x है तो हमें यहाँ पे भी क्या चाहिए? delta x tends to 0, so that we are able to apply the definition of differentiation. And since here delta t is there, we have to replace it by delta x. So already we have proved that as delta t tends to 0, delta x also tends to 0. Now this equation whatever maybe we have got here, I am denoting it by equation number 2, and here we have replaced delta t tends to 0 by delta x tends to 0 from which equation? First equation, isn't it? Now we are using given condition. What is the given condition? X and y are differentiable function of t. So write down the given condition. Since x and y are differentiable function of t, then if x is differentiable function of t, then it will be denoted by dx by dt. This is given condition. And y is differentiable function of t, then it will be denoted by dy upon dt. Already we have discussed on it. If this differentiation exists, means which limit exists? Limit delta t tends to 0 delta x upon delta t, and if this differentiation exists, means which limit exists? Limit delta t tends to 0 delta y upon delta t. This result we have got from the given condition that x and y are the differentiable function of t. अब इसके बाद में का पार्ट आपको बहुत अच्छी तरीके से समझना है. Observe this limit. Is it the numerator? Check that. Is it the numerator? Limit delta t tends to 0 delta y upon delta t. It is already given to us that this limit exists. और ये जो डिनोमिनेटर में का लिमिट है, लिमिट डेल्टा टी टेंड्स टू 0, चलो यहाँ पे हम डेल्टा वाई बाई डेल्टा टी अच्छी तरीके से लिख लेते हैं, डेल्टा वाई अपॉन डेल्टा टी, एंड इन द डिनोमिनेटर डेल्टा एक्स अपॉन डेल्टा टी. दिस डिनोमिनेटर, दिस लिमिट ऑल्सो एग्जिस्ट it is given to us because x is differentiable function of t means this limit exists, differentiation exist हो चुका है, इसका मतलब ये limit already exist है. These are the given condition. Now limit in the numerator also exist and limit in the denominator also exist according to given condition, and that's why we can say that both the limits on the right hand side of equation 2 exist. So here already we have given the reason which condition we are using to say that these two limits exist. So therefore both limits on right hand side of equation 2 exist, isn't it? So both the limits on this right hand side exist, and again if limits exist means what, there the value of this limit कहाँ पे exist होता है, रियल नंबर लाइन पे. तो ये लिमिट फंक्शन की वैल्यू क्या है, कोई तो भी नंबर है ऑन द रियल नंबर लाइन. सो लेट अस सपोज दैट लिमिट ऑफ दिस फंक्शन इज 10. सो लेट अस कंसीडर दैट दिस लिमिट एग्जिस्ट, यानी इसकी वैल्यू एक रियल नंबर है. तो हम न्यूमरेटर की वैल्यू कंसीडर करते हैं 10, और डिनोमिनेटर का जो लिमिट है इट इज ऑलरेडी गिवन टू अस दैट dx upon dy is not equal to 0. So this differentiation is not equals to 0 means this limit is also not equals to 0 means denominator is non-zero number. चलो डिनोमिनेटर का लिमिट कुछ तो भी 5 कंसीडर करते. इनके डिवीजन से जो नंबर मिलेगा हमें 2, दैट 2 is nothing but value of this limit. यानी ये लिमिट ये दोनों लिमिट पे डिपेंड है, तो ये दोनों लिमिट तो ऑलरेडी एग्जिस्ट हो चुके हैं, तो इनके डिवीजन से जो नंबर एग्जिस्ट होगा वो इस लिमिट की वैल्यू होंगी. यानी ये दो लिमिट एग्जिस्ट हो गए तो ही ये लिमिट एग्जिस्ट होगा, isn't it? And already we have given the reasons that both the limits on the right hand side exist and even denominator is non-zero number means this limit also exists. So therefore a limit on left hand side of equation 2 also exist, and if this limit exists then according to definition, चलो ये लिमिट एग्जिस्ट हो गया तो किससे डिनोट किया, dx by dt. अगर यहाँ पे डेल्टा x by डेल्टा t है तो dx by dt, यहाँ पे डेल्टा y by डेल्टा t है तो लिमिट किससे डिनोट किया, dy by dt. if this limit exists so then can I say that यहाँ पे क्या है, डेल्टा y upon डेल्टा x है, तो ये किससे डिनोट किया जाएगा, dy by dx, and is denoted by dy by dx. Now all these values we are substituting in equation number 2. Let us see what result we will get if we are substituting these values in equation number. So therefore we can say that equation 2 becomes, now observe this left hand side of this equation 2. So this limit already we are told that it is denoted by what, dy by dx. On the right hand side this limit already here we have given the reason, it is denoted by what, dy by dt. So it is denoted by dy by dt, and the limit in this denominator is denoted by what, dx by dt. So dx by dt. So in this way we have proved this formula. Observe this formula, and this formula is applicable to find out the differentiation of parametric function. So in this way we have discussed the definition also and the important formula also to find out differentiation of parametric function. So in the next video we will solve the example from next exercise means 1.4 applying this formula to find out differentiation of what, parametric function. If you think that these videos are very helpful to you, so please like the videos and share these videos with your friend. And if you are new on my channel, so please like the channel, subscribe the channel, and hit the bell icon so that you will get notification of every newly uploaded videos.